Hey there, this is a video of lesson 3. If you may have missed it in class or if you want to go over it, um, pause whenever you need to pause to copy something down, or rewind if you missed something, and hopefully this is helpful for you. So lesson 3 talked about measures of central tendency, which is really us finding out where the center of our data lies. So once we've collected data, and we report it, we want to know a lot of the times where the center is. So first, we talked about some ways to show or display the data that we've collected. And these are just some examples that I pulled off the internet, these pictures. So I'll give credit to whoever created these, thank you. But this is an example of a histogram. It looks kind of like a bar graph that you would have experienced, and it's just showing, using the heights of these bars, the frequency at which something's happened. So in this case, this is the birth weight of lambs, so it shows the frequency at which a lamb was born at a certain birth weight. Here we have a dot plot. It's again just showing the frequency with which people answered a certain number, so in this case numbers of brothers and sisters. So, for example, 1, 2, 3, 4, 5 people said they had 2 brothers and sisters. Here's called a stem and leaf plot. In this example, we're talking about test scores. So the stems here represent test scores that have values in the 40s, 50s, 60s, 70s, 80s, 90s, and 100. And so each leaf is the end of that number, so here 66, 66, 68. And then we have some scatter plots, which we'll talk about further in the future, but they compare 2 different types of data sets. So in this case, we're comparing a person's arm strength to their grip strength, and we're going to talk more about these as we go. So the measures of central tendency that we're concerned with might be familiar to you. We like to find the mean of data, we like to find the median, and we like to find the mode. All 3 of those represent different centers of data. The one that you're probably most used to is the mean. We calculate a type of mean to give you a grade in any sort of class. We like to know the average or the mean score on tests a lot of times. So these are 3 different types of measures of central tendency that we'll use. You can have no mode, which means there's no data point that occurs most often. You could also have more than one mode, meaning maybe 2 or 3 data points occur at the same frequency that is higher than all the rest. So I'm going to show you how to calculate mean and median using your calculator, and we're also going to use those operations to find standard deviations and some other things in the future. So even if you can calculate a mean or a median by hand, it's going to be important to know how to do it on the calculator. In order to find the mode, we have to actually look at the data and figure out which number occurs the most. So we can do that first. In this data, the number, or the price for a round-trip flight from Chicago to Mexico that occurs the most is 397. So 397 would be our mode here, so we can document that. So I'm going to go into my calculator now, and I'm going to show you how to calculate a mean and median using the calculator. So the first thing I'm going to press is the button that says Stat. And then I want to edit a list, so it's the first option. I can just press Enter right away. Notice my first list is full, so I'm just going to slide over to the other list. It's important to take note of the number on top, L2. I'm going to need to know that. So I'm just going to enter the information in here by typing it in and hitting Enter every time. So if you need to pause, and if you have a calculator at home, enter that in. So once I have my list filled with all my data points, I'm going to press Stat again, and I want to slide over to Calculate. And the first option is one var stats. It means we're calculating using one variable, which is what we're doing, the prices of round-trip flights. So I'm going to hit Enter. Then I'm going to have to press the yellow key, the second key, and I'm going to choose down here. I used list 2. That's above the number 2 button. So you can see I'm calculating this on list 2. I hit Enter, and I get a bunch of information. When we calculate a mean in the calculator, it's going to report X bar, X with the bar on top. That's this first value of 527.8571429. And of course, we'll round that in a test or a quiz. If I have a sample, which I do, the symbol for mean is X bar. If I were to have a population, I would call it mu, the Greek letter mu. The calculator will always report X bar. If you know the information came from a population, you should report it as mu. In this case, we had a sample, so we do X bar. Now I have a whole bunch of other numbers that we can get to in later lessons, but if I arrow down till I see MED, that'll tell me the median of the data, and in this case the median is 427. So we're going to use this calculator method for other values. You can see there's a lot of information here. So it's good to get used to being able to enter your data and get these one variable statistics calculated. So in class, I'd have you try this one on your own. So I would stop talking and you would do this on your own. So what I would like you to do is pause this video and go ahead and try this on your own if you can. And then I will tell you what I got. So I put my data in and I get that I have a mean, and it's a sample again, so I'll report it as X bar is 130.2. I get a median value of 115. And let's look to see if there is a mode. It doesn't look like any number occurs more than once, so there is no mode for this data. So something that happens when we collect data sometimes is that we get these things called outliers, and they're data entries that are not really representative of all the rest of the information. They tend to have an effect on where the center of the data lies. It has the greatest effect on the mean. So for example, I have this list here of students in a college statistics class, and I have a lot of people that are in their 20s, 20, 21, 22, 23, 24. And then I have this person right here who's 65. So that person we would consider an outlier. They're way outside of the normal data point that's in the 20s. They're going to affect the center of the data, so we call this person an outlier. It won't affect the mode because the mode is just the number that occurs most often. It'll affect the median slightly, but it'll really have an effect on the mean. So if you want to, you can plug the data into your calculator using 65, and then you can also plug it in omitting the 65, and you can compare. And what we found in class is that the mean age of these students is about 2 years different when you have this 65-year-old student to when you don't have the 65-year-old student. So it's a pretty significant difference when you're talking about ages, if you want to know the mean age and it's 2 years difference, that's pretty significant. So we need to look for these outliers. So one last thing is when we collect our data, we can find the center. We can also create these data displays like I talked about at the beginning, histograms, dot plots, stem leaf plots, and scatter plots. And we want to look at the shape of the data. That's one of the reasons why we put it in one of these displays, because the shape will tell us some things. One type of display is a symmetric distribution. One type of distribution. We'll talk a lot about this in the next unit. It's where if we find the center, which is going to be right in the middle in this type of display, it's symmetric about this center. A uniform distribution looks a lot like this. Sometimes it won't be perfectly flat on the top, but it'll be close enough. That means that any data point here has occurred about the same amount of times. If I have a graph where I have a whole lot of data points here and then it kind of slopes off to the left, I'll call that data skewed left. So we kind of have what's called a tail. And we name the distribution where the tail goes. The tail goes to the left here, so we call it skewed left. Down here, we call this skewed right because the tail goes to the right. And data that is skewed to the left or right is going to drag the mean further away from the middle. So here the mean is right in the middle. Here the mean is not going to be in the middle of this big group of data. It's going to be pulled this way because of the data points to the left. Same thing here. The mean is going to be pulled to the right because of these data points. So that's it for measures of central tendency. There was some classwork. Go ahead and get with me if you want to know what that is, and you can do some practice and ask some questions.